Well, good afternoon, everyone. Thanks for joining me for today's session. I'm going to be talking about managing open source vulnerabilities on the mainframe. And my name is Emre Tunar. I am a director of software engineering at Broadcom. I'm responsible for our mainframe security product portfolio of products. And also, I lead our strategy and policies around secure software development lifecycle management and product security incident response at Broadcom's mainframe software division. So the topics that I'm going to cover today, first we're going to talk about vulnerabilities on the mainframe and with a question mark. The reason for question mark is mainframes are perceived as one of the most secure platforms that you can run on, right? It has a good reputation. It has backed it up over the years. And you may be asking yourself, hey, do I really need to worry about vulnerabilities on the mainframe? So we're going to try to answer that question. Then we're going to take a look at some vulnerability management standards and terminology. I call these magic quadrant of vulnerability management, TLAs, or three-letter acronyms. While vulnerability management is relatively new to the mainframe platform, it has been an ongoing challenge for our friends on the distributed side. And over the years, they have developed a number of standards and frameworks that help management of those vulnerabilities much easier. So as we get into vulnerability management on the mainframe, we're taking advantage of those that already exist. So it's important for us to understand and utilize those so that we're part of the enterprise ecosystem. And lastly, we'll take a look at some resources and best practices on what we can do and what our customers can do to help reduce their security risk around software vulnerabilities. As I go along, please feel free to ask questions. We'll see if we have time at the end as well, but again, feel free to stop me and just ask the question. All right, so let's start with the first topic, vulnerabilities on the mainframe. As I mentioned, security has been at the core of the platform from the very early days. The security model and the architecture has been built with the premise of a secure platform. While that's true, at the same time, we've been opening up the platform to new workloads. We've been building REST APIs. The application development on the platform is not what it used to be 25, 30 years ago. John talked about it at his keynote today, right? We have Java applications running on the platform. We have a lot of open source and increasing usage of open source on the platform. At the same time, the platform is also as good as the actions you take to protect it. It's a securable platform, but if you don't take the right actions, you cannot make it secure, right? It's not inherently secure. You have to take action, and not taking action makes it insecure. So, as an example, if you were, let's say if you were to install the latest and greatest alarm system, home security system in your home, right? If you don't configure it right, if you don't turn on the right features and settings, it's not going to do a whole lot of use, right? So it's important to take advantage of it, configure it, take advantage of the features that it provides. So when we talk about software on the platform, what are some of the categories of software that we need to consider? Homegrown software. A lot of our customers develop their own software. Vendor software, Broadcom being one of the vendors. You can see many other vendors out there with their booths. Our customers consume our software, right? So what are the things we need to consider for those? And of course, open source software. It could be embedded in vendor software. You may be using it in your own homegrown software. So it's important to understand where they reside and how do you protect against it. Any questions so far? Comments? Okay, so let's rewind back to last December. How many of you are familiar with or have heard about Log4j vulnerability that emerged back then, all right? Good. So I think that was kind of a wake-up call for a lot of people working on the platform, right? While we knew the platform was susceptible to these vulnerabilities, we haven't really seen such an impactful and such a widespread impact from an open source vulnerability in the past, right? So that kind of, I think, got everybody thinking more and more around this. And sometimes events like this can trigger a chain reaction, right? And in a good way, right? Now that we understand and we've seen a prime example of a vulnerability that can impact us, what do we need to do, right? What do you think is the number of major software vendors for the mainframe platforms that did not have any products impacted by Log4j? Right, 0, right? Let me state that again. All the major software vendors you can think of that provides mainframe software had at least some products that were impacted by this vulnerability. So the problem exists, right? And the challenge is the problem is getting bigger and bigger every day. So here's a look at number of publicly disclosed vulnerabilities over the last 10 plus years. You go back 10 years, hovering around 5,000, right? Look at last year, 4 times that, more than 4 times that. And it's on track to be even higher this year. So the problem is getting bigger and bigger. So we got to do something about it, right? You got to have something in place to help you mitigate your risks around these software vulnerabilities. Okay, so let's take a look at some of the common terminology and standards that exist on the distributed world that we're extending and using it on the mainframe platform so that, again, we're part of the enterprise ecosystem. There's no need to do things differently for the mainframe. Let's take advantage of what they have built up already. So the first one of these is CVSS, Common Vulnerability Scoring System. How many of you are familiar, heard about it? Okay, good. So CVSS, as the name implies, it's a common framework to provide a score in the range of 0 to 10 that helps articulate the characteristics and the severity of a vulnerability. It kind of gives you a normalized way to look at vulnerabilities and provide a score that can help you prioritize it. The system included the reference document here, so you could go read in more detail. But the basics of it is, again, you have a rating of the severity match. So, for example, from 9.0 and up, it's critical. 7 to 8.9 is high severity. And it also comes with what's called a CVSS vector. So that's the string you see at the bottom there. And it's a standard formatted way that shows the metric name and the value specific to that vulnerability. We're going to take a look at it in more detail in the next slide. I've given this example. So as I go through the presentation, you'll see me referring to the specific Log4j vulnerability. So this is an example I'm using that reflects the severity, the CVSS score for that vulnerability. It had a max score of 10.0. So here's the anatomy of a base CVSS score. This is actually a screen capture of a CVSS calculator that's available on the first.org site. Very useful site to learn more about CVSS. Like I said, the specification is there. There's a calculator there. There's a training that you could utilize for free that they provide. So if you have developers that you need to train, very useful resource. So the way CVSS scoring works is basically there is a number of predefined metrics that make up that score. And depending on what value you define for that metric for a specific vulnerability, the score changes, right? So for example, attack vector is one of those metrics, and you could select one of the values such as network or physical and et cetera, and it will adjust the score for you, right? So this shows the filled values for the Log4j. And again, these metrics kind of define the characteristics, right? By looking into these, you can better understand what this vulnerability could do to your systems, right? On one side is the characteristics around the attack vector, the complexity needed. Do you need any privileges to be able to exploit this vulnerability? On the other hand, it's the impact scores. So does it impact confidentiality of my data? Does it impact integrity of my system? Does it impact availability of my system? Does it lead to a denial of service? As I mentioned, the vector string kind of encodes and represents that value. So you can see that. I highlighted at the bottom the value pairs. So AV means attack vector, column N is meaning network for that value, right? So by reading this, you can kind of understand as you get more familiar with it and decode what it means. But again, the calculator, very useful resource to use. Okay, in addition to base score, you may also see a temporal score from time to time. What temporal score does is it gives a different perspective on that vulnerability and adjusts the score downward sometimes to, again, add another perspective to it. What it adds is about the exploitability of the vulnerability in the current environment, and also what's the remediation level. This score is typically dynamic. It's going to change during the life cycle of the vulnerability, because when a vulnerability is first discovered and announced, there may not be a fix for it yet, right? So if there is no official fix, the second metric there would be unavailable, right? And that's a higher level risk than when there is an official risk for it, right? So similarly, exploit code maturity. Just because a vulnerability exists doesn't mean people have figured out how to exploit it yet, right? So is there any active exploit proof of concept out there that people can grab and take advantage of? So those are the additional information that gets added in to give a different perspective on the vulnerability to help you prioritize it better. Okay, so we've covered CVSS. Next three-letter acronym we're going to talk about is CWE, Common Weaknesses Enumeration. This is a community-developed, think of it as a dictionary or an encyclopedia of software vulnerability types. So you probably heard about things like SQL injection, right? Or improper input validation and things like that. So these are predefined set a list of weaknesses that could exist in software. It allows us to use common terminology, common reference when we're talking about these problems. So the three that I listed here are the ones that were associated to that Log4j vulnerability, right? This is a community developed and maintained list. They continuously enhance it. They have been very focused on trying to change the language such that it's reflective of the actual weakness rather than the symptoms or the outcome. So for example, we commonly know it as SQL injection, right? But they have been diligent about, okay, that's just the output effect, right? But what is the weakness itself? Well, it's actually insufficient neutralization of the special elements in a SQL command, right? So they've been very diligent around improving this continuously. Sometimes they break things down into more granular CVEs to better articulate the problem. They add new ones. So for example, last year, one of the new ones that was added was something like insecure design. Sometimes the security issue is just a bad design, right? So they continuously enhance this. There's also a CWE top 25 list that gets published yearly, looking at what are the most common ones that we see out there. So very useful resource. Next one is CVE, Common vulnerabilities and exposures. So this is a US funded and sponsored registry of public vulnerability disclosures. They essentially help us identify a specific vulnerability in a specific software, right? So it's in the form of letter CVE dash the year, four digits for representing the year it was disclosed, and then dash, typically a sequential number that gets incremented throughout that calendar year. So the one for the Log4j vulnerability was CVE 2021-44228, right? So it helps us refer to the same thing when we're talking about it, right? There are many vulnerabilities that exist in Log4j. Which one are we talking about? Well, we're talking about 2021-44228, right? So we know we're talking about the same thing. The other benefit it provides is it allows the vulnerabilities to be disclosed with minimum set of information. So it's a system where there has to be a minimum amount of information that the vendor discloses, right? There are what's called CVE numbering authorities that are part of the system and are authorized to register and issue new CVEs for their scope. So for example, software vendors like Broadcom, right? We are a numbering authority. We can issue CVEs for our own software. Many open source projects out there, they are CNAs. They can issue new CVEs for their own software. So again, very useful resource. The other benefit of this is they provide access to this in a machine-readable way. So through APIs and its other integration points, you can integrate your own software tools, or there are many other software tools out there, whether it's open source or commercial, that utilizes this as a resource to provide information and help you solve some of the challenges you have. The last one in our Magic Quadrant is NVD. This is, again, US government-funded National Vulnerability Database. It kind of brings all the information together. This is one-stop shop where you could go look up different information on the vulnerabilities. It gives you the CVE number, it gives you the description and details, it refers to other sites that has information about it. It adds a CVSS score, so that is typically not available when a CVE is issued, so this is where it comes in. NVD has their own analysts, as well as they utilize security analysts from other commercial companies that analyze and assess and validate a CVSS score. So again, very useful resource for us. Okay, last section, resources and best practices. So what are some of the resources available for us for mainframe specifically, right? So we looked at the standards that are universally available, right? So we're going to focus on mainframe resources next. So let's take a look at vendor software, right? One of my biggest recommendations to you coming out of this is patch, 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 right? You got to patch the vendor software you run, right? Well, how do you go about doing that? First of all, you need to know what security fixes exist, right? So one of the advantages we have on the platform is that we have a common packaging system that IBM has implemented on the platform. Many of the software vendors utilize it, SMPE, right? So IBM has enhanced SMPE, introducing a new error hold type called SecInt, which stands for security or integrity fix. So this enables customers to be able to identify security fixes for the software that they use among every other maintenance that exists for that software, right? So easy way to run a report, get a list of security fixes for software A, apply, and you're good to go, right? So great advantage we have on the platform. They also provide a CVSS base and temporal score as part of it. So again, useful information to help customers prioritize these fixes. A high or critical severity fix is much more important and much more urgent to be applied than a medium or a low severity fix. Vendor alerts and notification, another great resource. Many of the major software vendors for the platform provides capabilities through their support sites or portals and et cetera for customers to subscribe for security notifications. So when there's a new security fix for a software that a customer may be using, they get an alert, right? It's an email alert that tells you, hey, software A has a new vulnerability. Here's where to go to get more information, right? For Broadcom, we call these security advisories. We also provide CVE information for open source software vulnerabilities that we're addressing as part of it. Again, many of the vendors are adopting similar practices. Last resource I will mention is CISA. CISA is the Cybersecurity and Infrastructure Security Agency, again, a government agency that has put a lot of focus on the software security and supply chain security. They have initiated what they call a known exploited vulnerabilities catalog about a little bit more than a year ago. Very useful resource. Basically, let me ask you this. How many of you have security analysts working 24/7, giving you information about, hey, what's being exploited out there? Do you have those resources in your companies? No, right? Well, US government does, and they partner with other private companies as well to bring all that information together, surveying what's being exploited around the world, right? And they publish updates to it. So they have created this catalog. They continuously update it. I'm subscribed to it. I get notifications several times a week, at least, sometimes multiple times a day, that tells me, hey, this vulnerability that's in this software is currently actively being exploited. And that gives you another piece of information to help you prioritize what you need to patch. Okay, so how do we utilize these, right? Integrate security and integrity fixes into your maintenance process and schedule. Our customers have their own maintenance process and schedule, right? The key message here is security fixes part of that? And do you need to define a specific schedule for them, right? That's going to be up to you, right? Every customer has a different risk tolerance, different procedures, and they need to define that specific schedule for them. But my recommendation is make sure you have a schedule to consume these. We put out these fixes, right? But if you don't consume them, they're of no use to you, right? So, and as vendors, right? I know there's a lot of vendors here. Let's make sure we're utilizing these standards that IBM has developed, right? Doing these things in a standard way on the platform makes it easier for our customers to consume these. Subscribe to security integrity fix notifications. So again, this is a recommendation to the end users and customers. This way you could get alerted, you could take action when you see an action is needed. Again, to vendors that are out there, if you don't have such mechanism, consider adding one, right? It gives additional ability to your customers to get alerted. And then subscribe to the CISA known exploited vulnerabilities catalog. Again, putting all these pieces of information together can help create a prioritization of what to patch and then implement that schedule to patch and roll out those patches. And then last thing is talk to your mainframe software vendor, right? And as I know there's a lot of vendors here, go talk to your customers, right? Find out what challenges they're running into. How do we help them better, right? This is a common challenge we have. And the best thing we could do to help our customers is to do things in a consistent way across the industry, right? We do a lot of things consistently. This is yet another thing we need to do consistently across the industry. Okay, you've seen this in the morning presentation that David had, right? I didn't steal it from him. I already had it in my deck. So, but it's a great articulation of the problem, right? When you think about open source software, we use a lot of it, right? And there is some that fits this picture, and some of it is actually worse than this picture, right? Because that person in Nebraska may have stopped updating it and maintaining it, right? So we're seeing actually more and more of this. And it's important to understand what you're using so that you can mitigate these proactively rather than in a fire drill after the fact, right? So what's the number one thing you could do? Identify and manage what's in your software. There are tools out there you can use, open source, commercial. They're called software composition analysis tools. They can help you find out what is in your software, right? They can scan your binaries, they can scan your source code, they can scan your repositories and give you an inventory, right? And the key thing is it's not just looking at the top level elements, right? You may be using Tomcat or Spring Framework and et cetera, but do you know what that component is using underneath? Once you start digging in, a lot of new components come out that you had no idea they were included in there, right? And you need to worry about all of those, right? So the first step is know what's in your software. Then you got to keep it up to date, right? You need to monitor for new vulnerabilities. Again, a lot of tools that give you that list also has integrations to some of the sources, data sources I mentioned earlier. What vulnerabilities exist for those software that you're using. It helps you identify it, and that way you could take the steps to mitigate it, right? This can give you real-time ability to respond to these, right? I'm using an open source software component in my payroll application, right? And a new vulnerability surfaces for that. My SCA tool alerts me about it. I can go and mitigate, right? Have a workflow to help you mitigate it. You need to triage it, understand, does it even apply to your software? If it does, take the steps to fix it. And again, the other aspect to consider is unsupported end-of-life components. This is a major problem, and it could put you at a really hard place when a vulnerability surfaces for that software. I'm not going to say if, because it's a matter of when, right? It will come up, and you don't want to be doing it under the fire drill. Do it proactively. Identify which components are end-of-life or no longer supported. You can get a lot of information about active community or lack thereof on these components and assess the risk and take steps, right? I think John talked about it today. If something is going to take you 3 years to replace, right, would you rather do that now or do it under the gun when there is a Log4j-like vulnerability that's breathing down your neck? And last thing is, don't forget about your software development tooling, the testing tools, CI/CD tools, et cetera, that you have. I think one of the ironic things that kind of surfaced when we were looking at Log4j back last year was we also realized that some of the tooling we use for software security was actually vulnerable to this vulnerability, right? So don't forget about those. You got to consider those as well. Are you keeping them up to date? Do you know what open source software they're using underneath? So in summary, vendor software for end user personas, what are the steps you can take? Implement security patch monitoring and management, patch, whatever frequency applies to your company, right? And then what is coming next, right? What are some of the new things that you can anticipate here? Software bill of materials is the next thing that you're going to start seeing. Actually, Zoe started publishing it. It gives you a list of components that are available, that it ships. You're going to see that from all the vendor software that you utilize. Vendors participate in the ecosystem, use the standards, adapt the standards that exist, help evolve those standards. Homegrown software, again, find out what's in your software. Monitor and triage vulnerabilities, monitor and mitigate unsupported end-of-life components proactively, not after vulnerabilities come out. And then, again, homegrown software, don't forget about your tool chain. So with that, are there any questions or comments? Rose? Mm-hmm. So very good point, right? There's multiple variables to consider. There's more software out there, right? So just raw numbers could be misleading, right? But yes, there's more software out there. There is better tooling out there to help us find these vulnerabilities, no question, right? At the same time, there are many more bad actors out there, and they're getting more and more sophisticated, right? So when you look at the overall risk picture, I think it does represent the raising level of risk, right? But good comment. Yes. And finding these vulnerabilities is a good thing, right? Because we're addressing them. So better tooling, better adoption of responsible vulnerability disclosure programs by open source communities, by vendors, they all help. Any other comments, questions? Okay, well, thank you for your time. And if you want to chat afterwards, I'll be around. Thank you.